Last part of 5.7 has to do with Descartes' rule of signs, another algorithm for figuring out zeros. If I begin with the polynomial x cubed plus 2x minus 11, I look at the number of sign changes in the polynomial. That's a plus, so that's not a sign change. That's a plus, that's a minus, so there's one sign change. So one sign change means there's only one positive real zero. So it's the number of sign changes and then any multiple of 2 less than that. But if I subtract 2, I get a -1, so it doesn't make any sense. I'll explain that. It'll be more clear in the next example. So then you plug in negative x into the function. So you carefully substitute negative x into the function, and then you simplify, and when I cube this, I'm going to get a negative x cubed minus 2x minus 11, so there's a negative, a negative, a negative. There are 0 sign changes, therefore there are 0 negative real zeros. Oops. So the only possibility for positive real zeros is 1, the only possibility for negative real zeros is 2, and the fundamental theorem of algebra tells me I should be looking for 3 zeros. So what does that mean? There must be 2 imaginary zeros, which is good because imaginary zeros always come in pairs. So 1 real, 2 imaginary, and if you graph that, it probably looks, something like this. There's only 1 real zero there. Let's look at this one. 2x to the 4th minus 8x cubed plus 6x squared minus 3x plus 1. There's one sign change. There's a second sign change. There's a third sign change. There's a 4 sign change. So there's 4 sign changes. So there's 4 positive real zeros, or 2 less, which is 2, or 2 less than that, which is 0. So I have a few options here. I can have 4 positive real zeros, I can have 2 positive real zeros, or I won't have any positive real zeros. So then again, I substitute negative x in, put in negative x, put in negative x, put in negative x, put in negative x. When I raise this to the 4th, it's still positive, 2x to the 4th. This will be negative, and so a negative times negative is a positive. This will be positive, so it stays positive. Negative times negative is positive, and then a plus 1. There are no sign changes. 0 sign changes. That's a delta for change. So 0 negative real zeros. So there can only be 0. Now if I had a couple options, I'd have, like say I had 3 or 1. I'd have 4 and 3, 4 and 1, 2 and 3, 2 and 1, 0 and 3, 0 and 1. So if there's multiple then negative real zeros, you have to combine them with each of the positive real zeros. So how many total zeros should I be looking for? 4. So if I have 4 positive real zeros, I won't have any imaginary real zeros. If I have 2 positive real zeros, no negative, I would have to have 2 imaginary. And if I had 0 positive real zeros, 0 negative real zeros, I'd have to have 4 imaginary real zeros. So these are the possibilities. So again, these are algorithms that help us determine what to look for. A lot of this is about what to look for, which technology has done a pretty good job of solving that problem for us. I'm just going to keep emphasizing training your brain, doing core workouts. When you strengthen these skills, you strengthen your overall ability to problem solve in mathematics. So that's Descartes' rule of signs. You will have the opportunity to show me that you can do that.